Hello, let's look at number 7. So, we have this little diagram here for both 7 and 8. An ant of mass m clings to the rim of a flywheel of radius r, as shown above. The flywheel rotates clockwise on a horizontal shaft s with a constant angular velocity omega. As the wheel rotates, the ant revolves past the points I, and IV. The ant can adhere to the wheel with a force much greater than its own weight. And then it says 7. It will be most difficult for the ant to adhere to the wheel as it revolves past which of the 4 points? Well, this is really just sort of a free body diagram question, right? So at the top, we have mg down, right? But then also the ant can apply its own force, kind of that guy, a stickiness force. So I have 2 forces down here, sort of a F from the ant, right? Here, at this point, we have mg down, right? We can actually have some friction up at this point too. And then we have this FA of the ant here, okay? And so the force that's going to actually be allowing us to go in the circle will be that FA, okay? And then 2 and 4 will actually be the same. So both 2 and 4, those will actually be really similar. But then 3 is where it's a little bit different. Here I'll have mg down, and I'll have FA up, okay? And so you notice at the top, I have both FA and mg towards the center of the circle, which is the way that we must be accelerating here in order to complete that circle. Whereas on 3, I have only FA towards the center of the circle. So I'll need an FA that's big enough to not only keep me going in the circle, but also counterbalance mg, okay? So the correct answer will be C, because in that point, I need my FA to be big enough so that even after I subtract mg, that this remaining part left over is going to equal to the mv squared over r. Or we can change it to the m omega squared r, okay? So that 3 spot will be the hardest because it needs to be bigger than mg, and it has to have extra left over so I can still keep going in a circle, otherwise he would fall off. Okay,